Let us start a fresh topic today. Okay? Yeah, good morning. Don't worry about the voice. Just wait on now only. So today class, new module has been started. Op-amp basics and amplifier designs. One of the interesting topics to learn. So already we have got the foundation on multi-stage systems, and one more basics we'll learn is differential amplifiers. Now let us have today two group of concepts. First is basics, we'll learn fundamentals, and we'll come to the amplifier designs. Today entire class will be on this. Okay? Tomorrow we'll do the problems practice based on these topics. We'll have some good number of topics to explain. So how I'm going to analyze these topics, try to see. In the first topic, we'll consider op-amp basics. In the first topic, we'll consider op-amp basics. In basics, what I want to explain for you. In the basics, whatever I want to explain for you is the first one. First, we are trying to understand the block diagram. Some basic fundamental points. How a block diagram will be, how a pin diagram will be, how a symbol will be, how an equivalent model, equivalent model. So all these issues I'll cover in first basics for you. So simple things there. Block diagram means what are the blocks we go. Pin diagram because it's an IC, integrated IC. So we'll have some pin diagram points, symbol and equivalent model. This is the first topic for you. That's called basics. After understanding these concepts, the next point we'll go is B point. Point number B. We'll cover the ideal and practical conditions of op-amp. So this is a very important step. Ideal and practical conditions of op-amp. 99% all these questions in op-amps we do in ideal nature. Practically we will not do. Maybe 1% sometimes we have to do it. Where to do that I'll explain in the classes. Practical issues will be very less actually. Total analysis will be going on ideal manner. So how to develop this calculations values. Ideally how much and practically how much. The typical conditions we have to see. Next point is very important called transfer characteristics. Transfer characteristics. We are going to study the behavior of op-amp by transfer characteristics of op-amp. So this is one of the best topic to understand the complete op-amp structure. In this we are going to see three topics I am going to explain. One is open loop. One is open loop op-amp analysis. Next one we have positive feedback. Next we have negative feedback. So this is about our today basic class. If this foundation if you are strong, coming classes will be easier for you. Called amplifier designs. Hardly I think three topics we have to cover in the class. First one is block diagram. Block diagram, pin diagram, symbols, equivalent models. Next, ideal and practical conditions of op-amp we'll try to visualize. The last is an important concept called from the graphical picture we'll understand how the output will behave with respect to input in op-amp designs and how to explain this mechanism in open loop systems, how to explain in a positive feedback and how to explain in negative feedback. A very important conclusions of the overall class because our applications are dealing with these three properties: open loop, positive feedback and negative feedback. So today class we are going for next module is second module is based on amplifier designs. Amplifier designs. Amplifier designs will come under which category here? Open loop or positive feedback or negative feedback? Means negative feedback, yes, it's the first screen pressure. After the break, this is the first screen. So negative feedback will give more stability for the amplifiers. Positive feedback will not give and open loop systems. That's why whenever you use this word amplifier designs, keep in mind we are going to design all the op-amp circuits with the negative feedback concept. So first we are trying to learn negative feedback in all classes. After that slowly we will enter into positive feedback in open loop systems. So this total class is being designed with negative feedback. We don't want to use a positive feedback, we don't want to use open loop. Because to get more stability for amplifiers, negative feedback is more preferred compared to open loop or positive feedbacks. So what are the amplifiers we have? I'll just give the list of the amplifiers. The first one we have is inverting amplifier. Today we are going to study. First amplifier is inverting amplifier. This is the first amplifier today. Inverting amplifier. The second one we have is non-inverting amplifier. Non-inverting amplifier. First one is inverting, second one is non-inverting amplifier. After this we have some special amplifiers called voltage follower. Voltage followers. Like our common collector, we can make voltage followers. And we have one more is phase shifters we can design. Phase shifter designs. So these are the four basic amplifiers. Inverting, non-inverting amplifier, some special amplifiers in analog electronics. One is a voltage follower amplifier, one is a phase shifter. Not only that, we have some techniques also. Inverting amplifier with a T network feedback. We have some special type of amplifiers with a T network feedback. With the T network feedbacks we are using inverting amplifiers. Same thing, non-inverting amplifier with T network feedback. So these are the two amplifiers which we are using a technique called T network feedback techniques. Why we use all these things we learn in the class. These are the two amplifiers with different issues. Now coming to only one amplifier is remaining. That is called differential amplifier is remaining. Another amplifier is a differential amplifier using op-amps. Till now we have used only a single input, inverting or non-inverting. The last amplifier we are using is differential amplifier. But whatever you study in the class, whatever the amplifier you study, they will not meet the requirement of ideal characteristics. So to make an ideal amplifier, we have to design a final design called as instrumentational amplifier. Instrumentational amplifier. The purpose of designing an instrumentational amplifier is it has to become an ideal amplifier. The other amplifiers are not ideal, but last amplifier will become an ideal according to the design. So they're all basic amplifiers, but any amplifier will not be ideal in nature. So to make it ideal, we designed a separate design called instrumentational amplifiers. Hardly this order who will study this module, okay, you have been completed successfully. So this is our today main course in the class. Okay, so our target is to complete up to here. Only two topics. The first topic is under basics, the second topic is under amplifier designs. So this is the module today we are going to complete in the class today. Okay, this is the module we are covering. After covering this module, okay, there are some important special parameters in op-amps. If time permits, I teach today, or tomorrow I teach the parameters. We will have a separate topic, that is, I'll give separate topic for that called offset calculations. Unwanted things will be filter, offsets we call, that measurements we have to do it. Sleeve rate, one important parameter is there. CMRR, one parameter. Gain bandwidth product. These are all the special parameters of op-amps. Let us take it as a separate chapter, a separate module to complete. Up to here, if we can cover just amplifier design part will be completed. So that also will join to this module, then we'll do the workbook practice. Okay? Workbook practice I'll start after completion of this module and next module called the special topics. If you want here only you can join it, otherwise we'll finish here only that module also. All the topics will cover here only because they are related to amplifiers. So let us complete that special topic also. We'll make one more edition of this topic. So that group of topics will be here only. Topic number 3, special parameters. Special parameters in op-amps. A very important topic. Special parameters in op-amps. In your exams, they'll fetch this type of questions also. So what are the special parameters we're going to cover in the class is? The first very important is CMRR using op-amp calculations. CMRR, common mode rejection ratio, we can calculate. CMRR. We already completed the CMRR in differential amplifiers, but using op-amps, how to calculate CMRR? So the calculation what you done is inside. Now we are doing outside of the op-amp CMRR calculations. So CMRR is meant for op-amp calculations, how to do. The next we'll go for offset. Very typical topic is there. Offset, one of the typical concept in op-amps. Offset is an important topic for GATE students. And next 2 topics are remaining. That is sleeve rate. This letter always tells about the speed of the operation. How much speed your output is responding with respect to input of the op-amp. A sleeve rate concept. And the last one we have is gain bandwidth product. Gain bandwidth product, which is called as FT. So with this you can stop the module called amplifier designs. So slowly one by one we'll try to cover this one. Today my job is today total up to 4:30 or 5. This module I'll explain you. Total module now it is going to start around close to 11 it is up to I'll spend this time up to 4:30. I'll spend the time only on this module. Okay? Because one of the best module to understand electronics. Very important also in exam point of view. Lot of questions will be there in workbook. Nearly I think some 40 to 50% module will be completed with this approach. Workbook may nearly 40 to 50% questions will be covered only with this concept. Whatever I have written in the board. That's why each concept, each topic should go into your mind. Then only doing the problems is comfortable and easy for tomorrow. Okay? So try to listen in a cool manner. Each and everything will be easy for you. So take these points. Very important topics here is this one. Is the most important ideas. Instrumentation amplifier. Here the most important points is this 4. These 4 are important. The other things are basic things only. Everybody can understand easily. So please complete up to here. Our journey will start now. We will end up this journey around 4:30. If I want half an hour extra, maybe I'll take half an hour extra for this class. So that today if we can complete this part, tomorrow Batin will not be there. We can go for to practice nicely tomorrow class. So if you are completed, please tell me. We'll start one by one the course. 11 it is now. Around 1 o'clock I'll use the break. 1 to 2 you can take break. 2 to 4:30. Okay? If I want some 15 minutes extra, I'll take 15 to 20 minutes. Otherwise 4:30 if it is completed my issue, I'll stop there. Next time we'll cover the issues. Kamlesh and Shavik said completed. What about the other students? If you are ready with the topics, we can start smoothly one by one the topics now. The countdown starts now to start the class. The first is the basic concepts we'll develop. Topic number 1. Yeah, completed and Kundas. Great. So let us start with the topic name op-amp basics. So how completed? Prashant, Samresh. Great. So keep the heading. First topic. Op-amp basics. Keep the heading. Op-amp basics. In this, all the sub-modules I'm covering in this one single slide. The first module is topic 1. So, topic 1 is your block diagram. First, how to write a block diagram for op-amp. Block diagram of op-amps. What are the blocks will be there? Means, the first block, you can see, the first block is dual input, balanced output is telling. You always take a differential amplifier only. But the differential amplifier should be like this. You should have a dual input is telling. So you have to give 2 inputs to the op-amp and you have to take the 2 outputs like this. So this is the first stage. Yesterday we have learned that there are 4 configurations. Dual input we can take, single input we can take, balanced output, unbalanced. But according to the application, here compulsory 2 inputs you have to give for me. That's why it's a dual input. And you have to take 2 outputs because the next stage is also a differential amplifier. Because if you want more gain, compulsory you have to use multi-stages, correct? At multi-stages he has given a provision of 2 stages or 3 stages maximum. We are using active loads. So 2 stages or 3 stages has given very high gain. So in our class, there must be some intermediate stage amplifier is required. So you can take one more amplifier here. One more amplifier to get more gain called multi-stage. So this is called dual input, again, dual input, but we'll take it as unbalanced. Suppose if I stop with 2 stages, unbalanced output is enough. So 2 stage amplifier I'm taking, maximum 3 stages you can take, okay, 2 or 3 max. So the first stage is dual input, balanced output. Second differential amplifier is dual input it is taking 2 inputs, but only 1 output I have taken from that. So why? Because here I stopped my amplifier design. So dual input, balanced output, dual input, unbalanced. Now what I'll do is, from this point, he kept one more block design. One more block design here called as level shifter we call. Level shifter. They kept a design called level shifter. So what is the purpose of getting level shifter here? What is the main reason for this is, you can see that these points are directly connected. So we call this amplifier name as direct coupled amplifiers. This is called direct coupled amplifiers. So in integrated electronics, we are not using RC coupled. We are using here direct coupled, where capacitors will not taken into account. In previous class when I am teaching voltage amplifier analysis, okay, there we have used RC coupling. Here we are using just a direct contact. So they are called direct coupled amplifiers. In direct coupled, there will be no coupling capacitors in the classes. If there is no coupling capacitor here, what is the problem here is, this amplifier will give the output here AC plus DC will come. Generally, if you keep capacitors there, it will block the DC and it will give the AC output. Because of direct coupling you have taken, as the size is less you want. So you have to direct coupling. This AC plus DC will come here also, because there is no coupling capacitors to block it. So finally AC plus DC is coming, but we are interested here only AC, not DC. DC should not come to the output, only AC amplification I want, not DC amplification. But in direct coupled, AC plus DC is coming. That is the reason why AC plus DC, in that only AC if you want, there is a technique called level shifter. What this level shifter will do is, this level shifter will make your DC to be 0. It will make. So the circuits generally, it will make the DC levels to 0. So total DC will become 0, and from that we are getting AC output. Okay, we are not interested what is the level shifter, all these issues. We want to know that in the block diagram there must be level shifters. And what is the arrangement I do for level shifting is, we take some common collectors only. It's not a big purpose. Common collectors with a constant current source we'll take. With a constant current source we'll apply. Generally we take some common collectors actually. With a constant current source if you apply inside, the DC will become 0. So only we'll get AC here. But final stage, you must require one more block here. That is called output stage. Output stage generally, we require to the output. Whatever the AC you got, you must get here. Output power should be more. Okay. Again you are getting AC, but the power level has to increase. You must get the power output here. Power output. If you want power output here, compulsory we require a power amplifier here. We use generally class B systems. Class B push-pull amplifier we use. Class B complementary symmetry we can use always. Class B amplifier you can write. Class B systems we use here. Okay. Class B is nothing but Q1 and Q2 are common collectors. Just two common collectors say a class B system we are going to provide for you. Okay. Here also we have common collectors. Here also we have common collectors. So finally you got the power output. I think really speaking, op-amp is not a single stage that I want to tell in my basics. It's a 4 stages are there. First 2 stages are providing the amplification for you. This level shifting stage is providing the DC to become 0 and AC will be delivered. And the final stage will keep some power amplifier class B so that it will deliver the AC output with a good power. So whenever you get a good power output, I think that meets my requirement. Okay. So this is about the total block diagram. That's nothing I explained today. First topic I'm explaining about the block diagram of op-amp. The first stage is dual input balance output I said. The second stage is dual input unbalanced. These two will give the AC plus DC because they are direct coupled amplifiers. Coupling capacitors are not there. Level shifter if you keep with the common collector transistor, AC output will come, DC becomes 0. And the output should come as a power output. We need a power amplifier. The best power amplifier we use is class B systems. Class B power amplifiers. Okay. So this is about the story of the concept. So if you complete up to here the concept about block diagram, what is the next concept I want to teach is pin diagram, how to write. Next is pin diagram. All the small issues I'll cover in one slide. The second one is observation on pin diagram, because it's an IC pin diagram. Op-amp is an IC. So how to represent a pin diagram you can see. It's a very simple IC consisting of 8 pins. This is an op pin. We have 1, we have 2, we have 3 and 4. One side 4 pins will be there. 5, 6, 7, 8. It's an 8 pin IC. It's an 8 pin IC for us. Here, if you don't take here balance, okay, अब दोनों का outputs नहीं लेते. Next stage is asking dual input. Next stage have 2 inputs. अगर 2 outputs चाहिए ना, उनके लिए इधर बोलते balance. Balance is a word will not come from you or me. It's application. When I have 2 inputs, you are giving to the previous stage. Then it has to give 2 outputs. That's why it is called balance. It's called dual. Okay. But at the final stage, we are giving to only one transistor called common collector. Common collector will have only one terminal. That's why we can take unbalanced. That is depending on the connections. We are taking these ideas. Okay. That is the meaning here. So it's a 8 pin IC. The popular you'll see is 741 op-amp. 741 IC. This is the number given in the industry. 741 IC is a very popular IC which will be used in most of the applications. Op-amp 741 we call. Okay, it's a code for this op-amp. 741 IC. Very popular IC. So this one represents here offset null we call this as. Offset null, and fifth one is also offset null. So what do you mean by this offset means? In the classes you can understand is unwanted inputs. Okay, in the operational amplifier, unwanted inputs will enter into the design. So if you want to understand what is that unwanted inputs, you have to wait for the topic number 3 called offset designs. Already in the syllabus I have given last topics, offset, I have to explain you that is called unwanted at this level. That unwanted things, if you want to nullify it, these 2 pins will be used. 1 and 5th pin are used for nullifying the offsets. Unwanted things we can nullify. Those I think 741, what is 741 is any path karna. Every industry when you are fabricating ICs, they'll use some number for it. Okay, it is a series number we can say. That series number is 741. IC we call. Whenever they will try to fabricate, they'll use some series numbers like that in industries. So this is a 741 IC, just they'll recollect it, it came from the series. Okay, in your mobile phones you will have some series. Okay, Apple, suppose iPhone 6 I said, it's a word series. iPhone 8, iPhone 9, this is a series we call. It's not the meaning that what is the meaning of 741. Okay, series has given like a 741 IC series. So this is about the concept. This is a nullifying your unwanted things. So for the future use, we kept this pins. And second pin, we call it as inverting pin. We call it as inverting input pin. This is called, third pin is non-inverting pin. So one is for inverting input, one pin, one is for non-inverting input. And we have some batteries here, minus VE, that is the 4th pin I'm giving. VCC, I'll go to the 7th pin. These are the things I'm using for pin number 4 and 7. This is called supply pins, 4 and 7. And the 6th pin we are using for output to take. So these are the pins I'm using. about the eighth pin? Eight pins are not used because all the pins are completed. My usage is completed. Then you can ask me, sir, then 7 pins are enough to design it. But one thing you have to understand, when you are preparing an IC design, one side how many pins you kept symmetrically, you have to design, other side same pins. Same pin number you have to design. That is the reason symmetrically we have 8, but it's a 7 pin IC, op amps. We don't want to use the 8 pin. 8 pin is not used. We're not using it, but it should be there in the pin IC. It's a not used pin. So this is about my pin diagram. Next we have a symbol. Generally how the symbol, most of the times we see op amps is, you see like an arrow symbol with minus plus, and we'll see some output here, and we have 2 inputs, and we have some batteries here, plus VCC, and one more battery we have minus VE. So this is called symbol representation of your op amps. So according to these pins, you can see here what pins I have used in the class is. This pin is a second pin, which is called inverting pin, and pin number 2. And a plus pin here is pin number 3, called non-inverting pin. I'm using like this. And VCC is here, 7th pin I'm using. And minus VE we are using here, 7th and 4th pin. 7th and 4th. These are the pins I have used. And the 6th pin, we are using output. This is the 6th pin. So what about this 1 and 5th pins are inside offset nulls. This is the offset we have inside. Unwanted things will be there inside. To nullify this, we have 1 and 5 pins. So like this I have pin covered all the pins. Only one pin I cannot use here. That is 8th pin I cannot use. So that is the reason in general we say 7 pin IC it is. But in fabrication they will 8 pin. But we say 7 pin uses IC. 741. Okay, 7 pin IC it is. So after completing symbol, we have one more is equivalent model how to write. Can you see the amplifier equivalent model handwriting? Is there any difference between our BJT and amplifier op amps? You can see the difference. In op amps, they have designed in such a manner, its input impedance is infinite, output impedance is equal to 0. They prepared op amps like this. Input impedance is infinite. So why sir input impedance is infinite means we have used a differential amplifier as the input, and we have used a swamping resistor technique. When you use RE dash, your input impedance will go to mega ohms. So you get mega ohms impedance here. So input impedance we are going to get a high impedance. So output side, what I kept here, you can see common collectors I kept in class B system. You know that common collectors whenever you keep at the output stage, its impedance will be 1 by GM, which is a low impedance. So that is the way input output you can see high low. That means the op amps will behave like a voltage control voltage source amplifier. So op amps will behave like voltage control voltage source. Yesterday I think in some video multi-stages we got this basics. Who will say input impedance is infinite? Output impedance is 0. Who will prepare like that? It will work like a voltage control voltage source amplifier. So op amps will behave like voltage control voltage source. The modeling we know yesterday we have seen amplifier modeling. This is Jedi. We have negative, we have positive. This is VD is the input. This is the differential input will go to the op amp. And output side we have some source which will produce some gain here. That is EAD, differential gain, into VD. We'll have some output resistance, that is Z0. This is your V0. So you can see this is a modeling called voltage amplifier model. I have used the concept of voltage amplifier model. Voltage amplifier model. So op amps can be described with this model because it's a voltage control voltage source amplifier. So VD is the input, V0 is the output. So if you want to send this VD 100% to this input impedance, then you have to prepare this one as infinite. That only we done. High input impedance we prepared for this. So that voltage will enter, current will not enter. So here EAD VD should come as output. Then output impedance we have to take it as 0. That is the reason I kept here common collectors at the final stage called power amplifier, class B systems. So this is the beautiness of op amps. So all the basics have been covered in the first issue itself. Okay, pin diagram we got the knowledge, and the symbol we understood it, modeling how to do it for your op amp inside. That is my modeling, and this is my block diagram. So these all issues I don't want to speak separately. All issues should cover in the first step itself. So please note down all these things, which will help a student to start the class. Main class I will start now. These are the very basic things first you have to learn. This is op amp equivalent model you can write. Op amp equivalent, AC equivalent model. Equivalent model. Equivalent in my sense is AC equivalent. Right, this is AC equivalent model. Rahman, I think class B, what is the meaning of this? If you want to understand, you must know the subject of power amplifiers. Okay? What they have done in electronics is EC students को previous years we have power amplifiers. But present years 2021 से syllabus में change कर दिया वो power amplifiers निकाल दिया वो. Power amplifier chapter is not there for EC students. And that is the main reason. Okay? Who is teaching for EC branches? Okay? We never want to teach power amplifiers because if power amplifiers is there, we'll teach. But in ESC syllabus, maybe basic questions they can ask in power amplifiers. That's why I'm thinking one plan I'm doing for that. If my time permits for me, power amplifiers I want to teach in the class so that a basic idea will come for the student. But if I teach power amplifiers, that EDC syllabus which I have to teach for electrical students will get disturbed. So that is the reason what I'm planning is first I taught 100% analog portion. Whatever the remaining portion is very less weightage for your exams. That is called P injection theory module. That module may take some 6 to 7 hours class. That I have already covered in the previous batch. That I'm making as a video for that recording video. So that video I'm compressing into two parts, part A and part B. What I'm thinking is that P injection theory only one module. I'll just give as a recording video. The remaining things, whatever is there in op amps, each and everything I want to cover in the class. I said in my first class that I want to teach that what I can say 555 timer. I want to give a recording video. But no, in the class itself I'll teach 555 timer. Okay, so that I can adjust for P injection theory. I'll give as a recording video because that is not important for my class. These are all important for my class because in the exams in GATE they are not asking, but ESC also only one mark will come, may come or may not come in my PNH theory part. The theory why I'm explaining is student will get some fundamentals. The topic will make it as a recording video for you. At the end I'll post that video for you. Remaining things will cover smoothly all the things. If time permits, I'll teach power amplifiers also for your batch so that you'll get this type of sub-modules. Class B means what? Class A means what? You'll get a good knowledge on the power designs. Okay? Let us make like that concept. That is my plan actually. I said Friday will be the class ending, but EC students electrical Saturday will end up the class. Okay? Because I want to add some extra modules for you to complete the subject in a good manner. Only thing you can keep for P injection theory for one topic, which is ESC for electrical students. I'll make it as a recording video. Whenever you have time, just break one topic. Okay, just listen to class for 15 minutes, one topic like that. Hardly some 8 to 9 topics are there, which will give good clarity for you about P injection theory. Okay, the topic you can listen as a recording video someday. Yes. The remaining things total we are going to cover in the class. Maybe power amplifiers still now. No batch I got, but if time permits for me, for your batch, I'll cover the power amplifier designs because I'm very interested to teach power amplifiers, but time will not permit. Syllabus many here. That is the reason I'm thinking. So if you teach to give students power electronics, nothing can be better than this person. Ghosh, I think for power electronics there is one more expert faculty is there. That sir will take. Okay, he's a good in power electronics. He will take that class. I think power electronics is not completed for electrical students. Electrical students go power electronics नहीं complete हुआ. Yeah. So what you're telling is good. Jedi is infinite due to RE dash. So if you want, you can write this technique. This is due to, why this is due to common collectors at the final stage in power amplifiers. And this is due to swamping resistor technique. Like that you can recollect. Swamping RE dash. Because of this we are getting high impedance. Output impedance is coming 0 due to common collector. Okay. Great. Harsh Mishra, okay, thank you very much. Great. Okay. Power electronics is not completed. Great. So one thing I think we'll do it. Satya also will spend the time so that the power amplifiers module, if time permits, compulsory time will permit, so that PNX and theory we can do as a recording video. Power amplifiers you can learn from my lecture. Okay. It will become a special module in my class, power amplifiers. So we'll make it because till now in any batch I have not covered that video. For your batch, if I cover it, I'll send to other batches also. Okay. It will be better that I'll make that video for the other batches as a recording video. So one time I'll invest the time for power amplifiers so that in the next batches also I can give as a recording video for the other batches. Let us make it. Okay. Just only that PNX and theory will give as a recording video for you. That I'm preparing for you. And remaining things everything will cover it. So this completes the story about my introduction. Impedance matching can be done easily. Yes. Z0 is 0 means impedance matching we can do it. Output we can do impedance matching. Input loading effect we can solve. That's why op amps are called ideal op amps. Why op amp became ideal? Because we set the impedances like this in the amplifier. So come to the next step. That is topic number 2. Topic number 2. Ideal and practical conditions. Practical conditions of op amp. You can say whatever we studied till now, we'll visualize the points in the class. You can see differential amplifiers, what we studied, what we gained the knowledge, we'll apply it. Suppose this is you write a symbol in a quick manner so that everything I can show you in the symbol itself. This is an op amp symbol where we have inside some resistance called input resistance. Okay, this is a negative, this is a positive. This is your input impedance, Jedi, will be there inside the amplifier. And this is VD, differential input from here to here. This is your VD. We are taking the output as V0 here. And the biasing voltage is plus VCC. And the biasing voltage here is minus VA, which is controlling your op amp. These two batteries will control the op amp. And we have here some resistance connecting to the output, which is Z0, output impedance, and we have some source here, that is AD into VD. So this is called AC equivalent model of your op amp. AC equivalent model of your op amp. This is the structure you have to remember always. Okay? Why the structure is like this means simple thing. It's a voltage control, voltage source device. Always remember, op amp is a voltage control, voltage source. Now the first point is ideally Jedi. We got the knowledge. I'm writing the points. Jedi, I'm indicating here. Your input impedance is equal to infinite ideally. Your input impedance is 1 mega ohm practically. You should have both the knowledge. This is ideal. If you want practical, you can reach to 1 mega ohm, he's telling. This is practical knowledge. So whenever you reach to 1 mega ohm, we can say that approximately you are infinite. That is a meaning called high input impedance. Okay, this is the first step. Concept number 1. So but this is a technique from where you got high input impedance technique. Just make it round like this, your notes. From where this technique came, you just have to indicate again the technique name you write. It is coming due to the technique called swamping technique. Swamping, resistor technique, we got this. That is RE dash is the technique for analysis. Differential techniques we have used. This is about my first class, which we covered in our lecture already. The next concept I am applying. Output impedance story, I'll show you here. Output impedance story. In this, if you go, your Z0 should be 0 we want. Z0 should be 0, which is an ideal answer. Ideal. But Z0, we can have a range of 1 ohm to some 100 ohms in between. We can set the value. This is called practical. This is called practical. So this completes my second idea. So what is the reason to get this is? The only reason we have used it is common collector at the final stages. Common collectors will be always low impedance. Rahman is asking why op amp symbol is like a triangle. It is not a triangle here, it's an arrow. What do you mean by an arrow? If I just hit an arrow to you, it will not come back to me. That means that arrow always represents in analog electronics that they're all unilateral devices. They will not work output to input, they will work from input to output. That's why diode also will be like this only. Op amp is also like that only. BJT, whatever you see, that is also unilateral. Field effect cluster, that is also unilateral. But when you go to power electronics, they are not unilateral, they are bilaterals. Triarc, diarc, electrical students will try to learn. They are called not a unidirectional behavior, they have bidirectional behaviors. That's why they are working like switches, not like amplifiers. Because the main rule for amplifier is they should be like a unilateral devices. That's why this arrow represents not a triangle. It is telling that the current will flow from input to output. The current will not come from output to input, he's telling. Okay, only one flow, action. You cannot get opposite control. If you sit here and if you control something, nothing will happen to input. If you control here at the input, something will happen at the output. That is called unidirectional techniques. Okay? So this completes 2 answers. Coming to the next beautiful concept is AD concept. So each and every reason I'm teaching from the differential amplifier knowledge. AD knowledge. So how to take AD here is, your differential gain should be infinite actually we require. But AD, practically we are getting 10 power 4 to 10 power 6 we are getting. If I use 2 differential amplifiers as a cascading, 10 power 4 is coming. If I use 3 differential amplifiers, we are getting 10 power 6. Don't go beyond that because size will increase. 10 power 4 to 10 power 6 itself is a good gain. It's a very good gain. So this is enough for op amps. So op amps, the practical gain is 10 power 4 to 10 power 6. So what is the reason behind this is not more than active load techniques. I have used a concept of active load. Previous class I have shown you what is active load technique is. RC should replace with transistors. Active load we have used. Yes, sir, amplifiers are always unilateral devices, not bilateral. Okay? Or unidirectional and unilateral they are. So active load secret is this one. And coming to the next one, we have one more issue. That is a CMRR technique. If I have CMRR here, come to here. CMRR. CMRR is infinite. CMRR is around 10 power 4 to 10 power 6. Just like your AD, this also will maintain 10 power 4 to 10 power 6. This also will maintain 10 power 4 to 10 power 6. So this is the concept. So what is the technique we have used in differential amplifiers to achieve this? It is not more than a concept of current mirrors. We have used a concept of current mirror. Current mirror is helping me to reduce the concept of ESC, and not only that, active load also indirectly helping me to increase the AD. So both techniques will help me to increase the CMRR. These are the points we learned in previous module. And last one more we have is offset is there. One more is offset. Last point is offset. So if I consider here last one, offset. Offset means VI0 input offset, we call this as. The should be 0 is expecting, but the offset we are getting around 1 millivolt to 10 millivolts of input is generating in the op amps. So offset unwanted input is coming this much. Actually unwanted input should be 0, but it's maintaining some millivolts of input. That may create disturbance to your amplifier outputs in the coming classes. So offset means unwanted 1 millivolt to 10 millivolts we are getting. So to nullify this technique, in the future we are going to use a technique for this. To nullify this offset, we have offset nulls are there. Null points are there. To nullify this one, we have offset nulls, which are seen at terminal 1 in IC and terminal 5. We'll use some adjustments there called potentiometers. With the help of potentiometers, we'll adjust the offset null points. And finally, we'll make VS0, which is input offset voltage 0, will become, so that we can start amplifier designs. So this is the beautiness of the concept. What is the ideal conditions of an op amp? And what is the practical conditions? You should not forget these values. Infinite is 1 megohm practically. AD is infinite. Gain is 10 power 4 to 10 power 6. And output impedance is 0 ideally, but practically it is 1 ohm to 100 ohms can vary. And CMRR is infinite. CMRR should be same like our AD. And offset should be 0. For everything there is a technique in the boat. So this covers my concept number 2 in the class. If you write this diagram in a single page, it will be better for you. So how you are writing, I don't know, but in one page you can cover this issue. It's better. Each and every point, each and every technique you are seeing in the boat. Just I'll make this as star marks. Your techniques are this one. Here one technique is this star mark, stamping technique. Here one technique I have used is active load technique. Here offset null technique will be there. Here current mirrors and active load to improve CMRR. And here we have used like common collector techniques. So these are the techniques which we have used to make it as an ideal op amp. So op amps are called ideal op amps because we have done a lot of work to make this IC to work like an ideal device. So op amps will work like ideal devices. So please complete it. We'll move to the next point, topic number 3. Yeah, Shalini Kumari, thank you very much for your appreciation. And Parthasarathi, you're asking what? Inside the op amp, 2 differential amplifiers. Yes, inside the op amp we have 2 differential amplifiers which can give a gain of 10 power 4. If you take 3 differential amplifiers, we get the gain of 10 power 6. So limited is 3 max. Some op amps can be designed with 2 differential amplifiers, some op amps can go up to 3. Don't go more than that because size will increase. IC size will increase. Offset null. Julia. Japanese is an offset nulls. Why we have taken is to nullify that input. VS0 is an unwanted input is creating. That unwanted input to nullify करने के लिए we have 2 pins there in our class. Previously we have seen first pin is a null pin and a fifth pin. We are using some potentiometers in the next class. I'll tell you the trick also. Because of the potentiometer adjustments, we can make that input offset balance करके 0 कर सकते हैं. Okay? That is called null pins we have used there. So anyway, if you complete this idea, we are entering to the very important and very interesting topic to learn, where most of the people will get suffered with this concept. That concept how to understand step by step we are going to see in my class. Okay? Your grip level will increase with this subject now what I teach. Let's say the beautiness of my last topic in my basics. I'm coming to the final topic, which I call very important topic is topic number 3. It may take now 1 hour to understand this topic. So see correctly the concept. Transfer characteristics of op amp. Transfer characteristics of op amp. This is your topic number 3. So today only one thing I have to take help is, after doing some analysis on differential amplifier, we got some equation actually. Output to input some relation. It is not a conventional class to prove the equations. With the help of the equation, I'll teach you the class today called graph. So today don't expect any derivation for this. We'll just give the output equation for you called transfer characteristic equation. You can just visualize the equation. Nobody will ask me the proof in my objective question, so don't think about the derivation. Transfer characteristic equation is very important to explain our fundamentals today. Equation of op amp. So you write neatly this formula, which will help me to explain the content very easily. Transfer characteristic equation of op amp. What does that mean? V0 is equal to some alpha, that is called current gain of your transistor. Alpha IC. Okay? Is alpha capital IC, which is called DC current. Alpha IC into RC is coming, load resistance, into e power Vd by Vt minus 1. Because of one transistor, we got one diode equation. And another transistor wise, we got another diode equation, VD by VD, but maybe plus 1 we are getting. So because of two transistors, we got an equation like this, like an exponential forms. So this formula, how it is coming is not important at this situation. With that formula, how to create the graph is important for me. But so please concentrate on the parameters, which is valuable for us to teach. Okay? Derivation nobody will ask you, but equation you have to practice. This is a very interesting equation called transfer characteristic equation of op-amps. V0 is equal to alpha times of IC current into RC, e power VD by VD minus 1, e power VD by VD plus 1. So VD is your input and V0 is your output. Where VD is your input voltage for your differential amplifier, and V0 is your output voltage. So these are your two parameters which we are analyzing in the class. If VD changes at the input, what happens to the output voltage? But it came my mathematics like this. So let us think how the graph we can visualize. First my question is, in this suppose, case 1, I'm doing some analysis to try to understand. Case 1, suppose if VD is equal to, I have taken, suppose VD in the class. VD is VD I have taken in the class. So if VD is becoming your VD means what? Your input is 25 millivolts suppose. VD is nothing but 25 millivolts. Then exponential form if you observe here, e power VD by VD minus 1 you are seeing here, observation, divided by e power VD by VD plus 1. Just observe this exponential technique now. If anybody says VD is becoming VD, this form will become e power 1 minus 1 divided by e power 1 plus 1. So this is where you are getting, as VD becomes VD. Correct? Now my interest in the class is, when I can neglect 1 when my input is applied. If my input VD, if I'm increasing more like that, at what time 1 can be neglected in the equation I'm thinking. Exponential form has to be much greater than 1 I want. But really speaking, e power 1 is very close to 1. You just calculate it, e power 1 will be how much? I think I missed to bring calculator. E power 1, just tell me the answer for it. How much you are expecting? E power 1 value. E power 1 value is how much? It comes around 1.7 something will come. Just one time calculate करके exact value बताओ e power 1. So please calculate e power 1. In the similar manner, e power 1 you calculate. Similar manner, case 2 if you see, second case. Your VD, you take it as 2VD. Such that e power 2 minus 1 by e power 2 plus 1. So then what is e power 2? You just calculate it. E power 1, e power 2. It is around 2.718. 2.718 e power 1. What about e power 2? Give me the answers for e power 2 also. E power 2 calculate करके बताओ. This is e power 1. What is e power 2? E square. Okay, e power 1 I understood. You have given the value put 2.718. What about e power 2? Please post it. E power 2. It is Kamlesh is telling 7.389. 7.389. This is the second value. In a similar manner, case 3 I am taking. Case 3. Your VD, suppose I made it as 3VD. My input is now 3VD times. Then what is the answer? E power 3 minus 1 by e power 3 plus 1. Then what is e power 3? Just tell me this answer also. E power 3 is how much? So I will go for an approximation to be accurate analysis now. E power 3. Kamlesh, e power 3 calculate करके बताओ. Sabrina is telling 20.08. Is it correct? Anupam does 20.08. 20.08. Good. 20.08. So can you come to the final one? Case 4. Case 4. Suppose if VD is 4VD I have taken, then it is e power 4 minus 1 by e power 4 plus 1. So what is e power 4 value? Can you decide it? E power 4. Let me know the value of e power 4 so that I will give a better approximation for you. E power 4 will be how much? 54.59. 54.59. Great. So now you can see that 4 values I have measured. E power 1 is 2.718. 1 is there. I am not neglecting because it is very close. So this value will leave it off. And the second answer got 7.38. That is also for approximation, much greater than 1. That is not also a good value. I have taken 20.08, which is much greater than 1, but that also I have not considered. To get a good approximation, this also I have not taken. I have taken this one so that nobody can say it is okay. It is close to 1. It's very far away to 1. A very better approximation I have taken. In place of taking e power 3, I have taken e power 4. So from e power 4 onwards, anything you take, it will become much greater than 1. So I have taken this is a better approximation. This is a better approximation I have taken. Better approximation. To say that e power VD by VD is much greater than 1. Like this, technical people started approximating the concept like this. That means e power VD by VD. Arpita, I'm seeing your answers, don't worry. Okay, 54.59 you said. 54.59, great. Arpita, I'm seeing your message, don't worry, I'm seeing it. By chance I missed your message, 54.59. The other people also given the same answers. Kumar Ujjwal, Jahnavi, who is this Bhattacharya, 54.59, great. So what is my theory here is, approximation if I want to do, these all things I'm neglecting, I'm taking that as my condition. So that means when your VD is becoming 4VD or above, I think here 1 can be neglected in the mathematics. So 1 I will neglect. That case when it comes greater than 4VD, we can neglect it. Okay, here 1 can be neglected. So with this knowledge, what I understood in the graph you can see now. With this knowledge, I will try to go to the next slide. Please complete up here. Now the story is clear. So we can have some better approximation that 4VD ke baad koi bhi input, whatever you are giving, 1 can be neglected in the equation. So like that we'll start the analysis now. Okay. So in the next slide we'll see the graph now. So this is my graph. See the approximation, how we done. This is your VD, and this is your V0. This is called transfer characteristics. Now what I'm doing here is, I kept some marking here called as 4VD in the class. Your VD is 0 to 4VD, I'm not talking. I want to talk about it is getting some constant answer like this. You are getting some constant output voltage in this manner. So this is the observation I have done. If it is anything you take, your answer is coming constant like this. So what is this constant? We call it as simply, this constant we call it as plus V saturation we call in amps. So we are getting some saturated output in this case. So how you got the saturated output? Now you can apply the principle here, equation, principle. What is that? Your output will become formula here, alpha times of IC into RC, okay, e power Vd by Vd divided by e power Vd by Vd, where 1 is neglected here. If 1 is neglected in the class, I think this term and this term will be cancelled, so that your output will become only alpha IC into RC like this. So every values, your output will become a constant output, because exponential forms will get neglected. So alpha times IC into RC is a voltage, is a constant voltage, is a constant value. It's a fixed value, you can say. The constant value, I'm speaking some name for that, called V saturation. So it has been saturated to that answer. Whatever the input you are giving error is, same answer is coming all the time, called plus V sat. But indirectly mean as alpha times IC into RC. So this is the story of op amps. It's the same story if I apply for the opposite side. If I apply for the opposite side, that is, if I take marking here, minus 4VT suppose. I have gone to minus 4VT concept. It's the opposite action. Here what is happening is, you are getting saturation this side in negative side now. Here also we are getting saturation, but in negative side. So this we call it as minus V saturation. Here we get a minus V saturation. So what is the meaning of this is? Your output becomes here V naught. It is alpha times of IC into RC. Here what happens is, we are neglecting this exponential form. So we get here minus 1 divided by 1. It's oppositely, exponentials will get neglected because it's a negative effect. So because of this 1 is cancelled, your answer is minus alpha IC into RC, which is nothing but minus V saturation. So one case you are getting minus V saturation, one case you are getting plus V saturation. So take this beautiful concept. It's a very beautiful concept. This is the story of the saturation, and this is the story of the saturation. Mathematics also you can write side. So we got two saturation levels in the op amps. So what about in between what happens? If anybody asks me, can you see that at this point what happens? At this point, what can happen? At 0 point, with my VD, what is happening here? Your output is equal to alpha times IC into RC. Alpha times IC into RC. Here, exponential of 0 will come. VD is 0, minus 1, divided by e power 0 plus 1. Exactly at the origin of my input. My output relation is this one. E power 0 is 1, 1 minus 1, it will become 0. So answer will be, it will be 0. That means whenever my input is 0, my output is also 0. That means whatever you are connecting from here to here, it is passing through origin. So you will have some exponential behavior up to some time. We have an exponential behavior, and here also we have some exponential behavior up to some time, because we are doing some approximation with exponentials. But after that, we have some linearity in the concept. After that, we have some linearity like this. We have some linearity. We have some linearity. This is your non-linearity up to here. Up to here, some exponential. So getting what you can say approximations are going on. Here also we have some approximations. So in between, we are getting some linear line. We get some linear points here. So that is possible. Your linear line is possible between Vt minus Vt less U should be inside, and here it should be plus Vt inside. So only in this portion you can make it linear. Other than that, it will become non-linear. So this is the way how the observation came for op amps. Okay. In this complete regions, where to use our subject, applications where I have to use. Means I'm seeing only two regions which are beneficial for us for applications. One is this blue color line is beneficial line, and this white lines are beneficial. But this lines does not have any meaning to do applications. So this part please eliminate it, and this part please eliminate it. Only study between Vt2 minus Vt1 study, or above 4Vt or below minus 4Vt. Try to study the subject. So there are two applications I can write. This region, we can use like a non-linear region. This region is called non-linear region, or we can also call it as saturation. We call saturation region. So in our class, non-linears are called saturation regions. So here also same thing. We can use this region as non-linear, or we can call it as saturations. Okay, these are called non-linear and saturations. Somebody else here, minus 1 will come is, here this exponential form, you are getting e power minus 4 is coming. 1 by e power minus 4, you will make exponential form in reverse. The value is 1 by 52 point something, it will become close to 0. So here 1 will dominate the quantities. 1 will dominate the quantities. Okay, that's why I have not written this point, exponentials. Only I have taken minus 1 by plus 1. It's a negative effect, that's why it's a reverse concept. So these are the non-linear regions or saturations. There is one more region in the class called as this one, blue line. This blue line, we call it as linear region, we call this as. This is called linear region. Or we can also call it as active region, we call. So linear or active. So this portion you can use for some applications. Okay, the blue line you can use for linear applications because output is proportional to input. And when you are crossing 4Vt, when you are crossing minus 4Vt, the output is not responding. It's a saturation voltage, which are considered to be non-linear. So where to use which application? I'll write side by. So for linear applications, for linear region, we have two applications we are covering in our class for linear regions. The first one is amplifier designs. Amplifier designs should be done in linear region. Second one, mathematical operations we try to do here. Mathematical operations. So these all things comes under linear region area. So these two modules we are covering today, tomorrow, these two modules will be covered. There is one topic called linear region analysis. So otherwise we are studying the class. Otherwise we are studying linear analysis first we are covering. That is called this region we are covering in the class. Where this region will be very close to 0. But these regions are close to infinite side. Non-linears are close to infinite side, linear is close to zero side. So these two areas are the main areas in op-amps. One is mathematical operations and one more is your amplifier designs in the class. Yeah, Jahnavi, if you want previous slide, just 1 minute. Yeah, cover Khadija. I'll go back for you to show you that slide. So this is linear regions, applications. And one more we have is non-linear regions also there, non-linear region. Okay, linear region and non-linear region. Non-linear regions we use here as we can design Schmidt triggers, very popular designs. Schmidt trigger we call, and we can design multivibrators. Multivibrators we can design. Schmidt triggers and multivibrators, some popular designs are there, which we can design here for non-linear applications. So this is about the situations of non-linear area. After covering these two things in the syllabus, I'll come to the last topic, which will cover the complete op-amps. 3 modules are there to cover. Okay. Yes, Chandramohan, this is the transfer characteristics. Okay. So doubt should not come because input to output, who will study that the characteristics we call it as transfer characteristics. We're studying the input to output relation. Most that op-amp can work in linear or non-linear. Don't ask me at this level because case studies I'm going to do step by step. Each case example I'll take and I'll tell you the conclusions. All things will come nicely step by step, so don't worry about that. First understand the regions of the op-amp. Where it will work, we'll see according to the design part. Op-amp will work in linear or non-linear, we cannot decide now. Okay? Problem करने के बाद examples करने के बाद you'll understand it. So please complete. This is my total picture about the op-amp behavior. So this is called your transfer characteristics of op-amp. This is called transfer characteristics of op-amp. One of the beautiful graph to understand the subject. Transfer characteristics of op-amp. So if anybody asks me, sir, a plus V set will be how much? Means you can just approximate to this answer plus V set C. So how much battery you are giving to the op-amp, that much you can approximate close to that value. And what is minus V set means? You can close it to minus VE battery. That means your op-amp output will get saturated to the maximum limit of your batteries. In the exam, how much the battery they have given, that will become your saturation limits for the op-amp. They cannot work more than the plus V saturation. They cannot work below the minus V saturation. That is the op-amp device analysis. So complete this beautiful concept. In single slide, we got the total picture now. Let us understand the situations now. Open op-amp first discussion for you. Next positive feedback. Next negative feedback. Some conditions, conclusions will be there. After getting a good knowledge on this, you are ready to start the amplifier designs. Okay? That is the thing we are going to do the job now. Lack of this knowledge, what I am teaching only, most of the students will feel difficult in op-amps. Now this topic will make you strong in the class. You will become more strong after listening this class. So please complete it. We'll go for case studies one by one. We'll analyze this graph beautifully by taking some modules like open loop system analysis, positive feedback, negative feedback. 3 topics I'll analyze now. And I'll investigate that which op-amp mode will work in which region. Op-amps will not work. One situation is there. Open loop op-amp, if it was suppose in non-linear, they cannot work in linear. If positive feedback is telling I work in non-linear, it cannot work in linear. Negative feedback is telling I work in linear, I cannot work in non-linear. All these cases we have to understand now beautifully. Okay, each topic of conclusion also will understand. Yes, sir, Shamnidas, what you said is correct. Minus 4VT above, it is close to minus 1. Minus 1 by plus 1. So we have taken exponentials are neglected because e power minus x, we neglected that quantity. Prashant Kumar, somebody is asking, previous slide, just one time. Who has missed the previous slide? Please note on it. We'll start the class from here. So be ready for the analysis. Maybe it takes 1 hour to complete that analysis. Maybe by 1 o'clock, these things will be completed. So 2 o'clock onwards, we'll start the journey on design part 1, amplifier designs. 2 to 4:30 or 5, exactly 3 hours if we take, maximum we can cover all the issues today only. Rahman, mathematical operation का meaning कोई नहीं है यार. Suppose you want addition, you want to add 2 potentials. Op-amps are telling we can add it. If you want to subtract, we can subtract it. This is called mathematical operations. That means op-amp is not only an amplifier, it can also be a tool for mathematics. Okay, in computers, in digital computers, laptops, wherever you see is mathematical operations we can do. That can be done by operational amplifiers. Okay, that is the meaning called operational. Shamnidas plus V said, why we nearly taken plus V C means whatever the answer we calculated, alpha times of IC into RC. IC is the operating current of your differential amplifier. RC is the load resistance. Alpha is 1. The total product value is always coming practically close to the battery positions. So why to take every time close? Take directly VCC, he said, for study purpose. Okay? The answers are coming very close to the VCC supply. That's why most of the times we take that as VCC directly and we study the classes without making complications. Every time to calculate operating current to RC, it takes a lot of time to study the subject. That's why approximately you can take VCC. So let us start our class. Keep the subheading, first subheading. In this topic, we are making first subheading. First subheading is open loop op-amp. Open loop op-amp. Let us understand the principle behind open loop op-amps. Nicely understand the concepts. Suppose I have taken an example for this to study like this. This is an example I am taking. Minus plus. The AD, suppose inside is a 10 power 6 I have taken. 10 power 6 means high gain it is. Op-amps will have high gain. Around 10 power 6 is the practical value I have taken. This is your output. And the positive battery here is, we can call this as plus V set now onwards. In place of writing batteries, you write saturation limits. Minus V set This answer is supposed to 10 volts given. This answer is minus 10 volts given in the problem. 10 and minus 10 symmetrical values generally we have to give in the op-amps. And the next we have is I kept here one resistor R to this point. One practical resistor I kept here in series to the op-amp. Okay. And positive side, suppose I made it as ground. Here I am giving some input signal as a signal like a small signal output. So this is the situation I am saying in the board. Here an open loop op-amp. Okay, we have given some input and we have some values. AD value is the differential gain, which is our open loop gain we can say. Op-amp gain is AD. We call 10 power 6 is the gain I have taken. 10 volts minus 10 volts is the package. Okay. The input is as a signal output, which is a small signal output, suppose. So when I want to study this analysis, shall we go for practical approach or ideal approach? If anybody asks me, most of the cases I never go for practical because all the practical values are very close to ideal values. So any question I do with ideal imagination. But in diodes we have not done like that. We have done ideal, we have done practical. BJT also, we have done ideal, we have done practical. In BJTs most of the time we have not done ideal actually, we have done practical. DC side is 0.2 we have taken and VDE 0.7. But here we have done everything in ideal nature because op-amp is an ideal design. So that's why the benefit here is we can use ideal conditions to develop this concept. So what is ideal conditions? One time we'll recollect, which I can use in the board. What are the ideal conditions? Generally I'll use in the class is input impedance will make it as infinite. Your output impedance will make it as 0. Your AD I'll use infinite. Your I plus is equal to 0. Your I minus will be equal to 0. This is the list of points which I use in my analysis. What is that I plus and I minus is non-inverting input current, inverting input current. Currents will become 0 because input impedance is infinite you have taken. So currents will not enter. Voltage will enter into the device. Okay, currents will not enter. I plus means non-inverting input current. I minus means inverting input current. Now how to explain this topic? Try to see now. If I write the modeling for this, AC modeling, it looks like this. This is R, this is VIN. Inside amplified model, we can present like this now. With ideal imagination, you said that ZI is infinite here, and we have some voltage source here, which is AD into VD. Next we have is a short circuit here, that is Z0 is equal to 0. This is your output. So nicely I am seeing your inside op-amp structure is like this. This is a voltage control voltage source diagram. Ideally you said input is infinite, output is 0 inside the device. There is one external R from outside. So if you see this concept like this, you can easily understand the situations now. What he's telling is, this is a negative sign, this is a positive sign. The current what is going here is I minus current. And the current going here is I plus current. Naturally, I plus will be 0, naturally, I minus will be 0 because no current will go to open circuit. That is the meaning he is telling in the ideal condition. So I minus and I plus will be 0 always. If I plus and I minus is 0, what about the resistance voltage drop here? According to the situation, what is the voltage drop? VR. VR will become I minus current is going into R. I minus is 0, but resistance is R. Answer is 0. So the voltage drop across the resistance became 0 in the class. So there is no meaning of resistor in this port. You may keep resistor also, we can directly short it. So can I say that the point which you have here V minus and the point here we have is V plus. There are 2 points here. According to the board, I can write now V minus is equal to VIN minus VR is actually the equation. This answer if you want, this minus this you have to subtract. Okay. So VIN minus VR, but V minus became VIN minus 0. So V minus became VIN. So this is the proof which I got for V minus in the board. So one thing is very clear in open loop system is whatever the signal you give, it will go directly to your inverting input if you go for inverting system. Just I'm taking an example of inverting. If I give some input, it will be directly going to V minus because the voltage drop across the resistor what you get practically is 0 because current is not entering to the op-amps. So these two will be the same. This is about V minus. So what about V plus? V plus, common sense, directly it is ground. V plus is 0. So V plus we got 0, V minus we got as VIN in the class. By seeing these two results we can say V plus and V minus are not matching in this theory. So in open loop system, I have been proved that the inverting system and non-inverting system ka inputs match nahi ho rahe. If both the inputs are not matching, we call the technique in our electronics as op-amp will work as a comparator. As a comparator. This is a very important statement. Op-amp will work like a comparator is telling. Suppose if V plus and V minus same ho gaya, it will work like a virtual ground or virtual short. So both inputs are shorted. We say both are equal, we say shorted. But it's not shorted because these two are not same. When they're not same, we can use not like a virtual short theory, we can use like a comparator because we can compare the voltages. So this is not used as a virtual short. This mechanism is working like a comparator mechanism. It will just compare the two values. That is the secret of open loop system analysis. You can understand smoothly the subject like this. It's not a very tough to understand. Each and every point I'm teaching there. So V plus and V minus both are not same. So op-amp will work as a comparators. It will just work like a comparator values. Okay, one good point. It works like a comparator. So the next point is what is the output voltage? How to find out? The next situation is output voltage, how to find out? Output voltage, how to find out? V0, how to calculate? So V0, seeing the diagram, easily you can tell the answer. V0 is nothing but AD into VD because output impedance is 0. So your output will be always equals to AD into VD. Where AD is nothing but your open loop gain. Open loop gain. Now one words AD is called as open loop gain because we are not applied any closed loop in the op-amp. That's why it is called open loop gain of the op-amp. So AD means open loop gain. So it is given in the problem around 10 power 6. Open loop gains are very high in the subject. Okay, it's very high gain amplifiers because of multi-stage concept. So what will be the output answer here is V0 is equal to AD times VD is nothing but V plus minus V minus is your V0. Always remember your VD is a difference of plus to minus. That is the difference of your differential amplifier. V plus minus V minus. Okay. So what is V plus here in the board? It is 10 power 6 is AD. V plus is 0 minus V minus is VIN. So this is the way I'm getting the value. So can I expect VIN, for example, in the problem is 10 millivolts I have taken in the problem. Small millivolts I have taken. So answer is 10 power 6 into minus 10 millivolts. So this is the answer. 0 minus means negative answer. 10 millivolts. 10 power 7 minus 10 power minus 3. It will become 10 power 4 volts with a negative sign. So it is minus 10 power 4 volts is coming. So whenever the answer is coming minus 10 power 4 volts, a student should understand. I think in the graph if you see, I can't believe that my answer is going below this battery here. You're telling answer is here, but output is coming here in the graph. So we should not believe the mathematics at this position. You have to believe the experimental graph. So in the lab, I think your graph will come like this. But that means in other words, any answer comes above this answer, you have to tell this answer only because you have saturated already in the op-amps. You cannot get more than that. So suppose if you get anything below this, that is your answer. But anything comes above, that should be saturation answer. If it comes in the negative, same approach. So I think your answer should be minus V saturation. So answer is minus V saturation. Minus V saturation is minus 10 volts. So this is wrong answer. This is correct answer. So don't write minus 10 volt for blindly because op-amps cannot go to minus 10 volt for. It can only go up to minus 10 volts because op-amps cannot work more than the battery limits. That is the concept we got in graphical analysis. So this completes my beautiful knowledge about op-amps. So finally I got a good conclusion. Where you are getting output means you are not working under linear region. Your output is working under saturation limits. So op-amps always works in non-linear region when it is in total systems because answer is coming there minus 10 volts. So a good conclusion has been arrived with this mathematics. A very good conclusion is, I can write a small conclusion here. Conclusion about this analysis. Open loop op-amp. Open loop op-amp with high gain AD will always works in non-linear region. It works in non-linear region, or we can say saturation. So these are the very golden points I can say in the subject. Golden analysis, wonderful points. Smooth concept you can learn like this. Your perfection will increase in the class if you can learn the subject like this. Op-amp will work like a comparator with this principle I understood. This is one important star mark for me. It's a comparator principle you have to use. And by saying this, I said that it works in non-linear area. It works in non-linear area. There's another star mark. So this is about the concept. So finally, the statement is one of the best statement at this level. So if anybody asks me, op-amps will work in which region in general? Okay, my straightforward direct answer to the student is they work in non-linear region. Because only one reason is there. Because your op-amp have high gain AD. Because of very high gains, I think your output is crossing your battery limits. That is the main reason it works in non-linear region in electronics. So this completes the first basic knowledge about open loop op-amp in electronics. But this IIT professors definitely will confuse you in exams. What is their thinking? I'll explain now. I mean, this is called general thinking what we done. We do some extra thinking. Let's say a special case in open loop system. I'll go for one special case now, which will disturb the minds of the student. So let us understand the disturbance, what they'll do in exams. So complete nicely this approach. First approach is very clear, I'm expecting. So I'm expecting everybody has understood up to here. This complete approach. This approach is very clear, I'm expecting. Yeah, Akash Mitra, thank you very much. Definitely you'll understand each point very clearly now. Maximum in BTech level they'll confuse you all these things because of not explaining each and everything like this in the steps. So now it will be a good clarity for you to study the subject. Okay? In open loop op-amps never speak the word virtual short theory because virtual short theory is a word comes if you can prove V plus is equal to V minus, but you have not proved it. V plus is not equal to V minus you proved. So it is not a virtual short, it's a comparator. You have two principles. Comparator either happens or virtual short happens. Here it cannot happen. Virtual short. It's a comparator rule, it is happening. Somebody is asking, how could you ask like that? 10 power minus 4 क्यों नहीं ले रहे? Why are you asking like that? I have shown you clearly the class. अब नहीं देख रहे इधर एक ग्राफ में क्या बोल रहा हूँ मैं any answer if you see here any answer comes below minus 10 इधर है आप but मेरा answer इधर है ना graph is teaching that I cannot put below that I will be always here but your answer came here so any answer comes here what I am doing this answer I am taking so I am not believing my mathematics I am believing my experimental graph so any answer below the minus V saturation it should be minus V saturation because your output cannot put beyond that in the graph so graphically we are understanding and we are writing the results like that okay so again you should not ask that question to me I clearly explained here again you are asking that question so this is about your first topic. First topic is very clear, I think, completed. Great. Let us have some special case here. I want to teach some special case. So, a special case you can see in the same topic, special case. What is this special case you can see? So, otherwise we can say some concept like this. In case of writing special case, suppose if you write the heading as open loop, op-amp, gain, AD is low suppose. This is the case actually we are developing. So keep the heading like this. In place of keeping special case, you write like this. Suppose in the exams, they are not given high gain, they are given low gain in the class. What will be the consequence? Open loop op-amp gain is low, he said. But in general we know, op-amps will have high gains. But they will tell in the exams, my op-amp is a bad op-amp. I have not designed properly. There are all things they will tell. Okay, that will disturb the mind of the student. Okay? That will disturb your mind. So he said that open loop op-amp gain is low, he said. Low means how much, sir? Low means you can take very less gain. So suppose my op amp is given again like this. This is minus, this is plus, this is your output, V naught. This battery limit is plus 10. Same question I'm developing, minus 10. Suppose your AD is at only 10 here. Then you take it as a low gain. Same R is there. Your VIN is 10 millivolts. Again I ask you the same question. Can you tell me what is the output? So I started applying the formula. V naught is AD into VD. Apply the formula. AD into VD is V plus minus V minus. AD is only 10. Low gain you said. V plus is 0 minus. V minus and VN same. This was same. Because the current will go here. I minus will be 0. And here V plus. This point you can see here only now. After getting experience. You can do here only 0 minus VIN you can write. Your input. V minus is equal to VN. So this answer will come as output is equal to 10 into minus of VN is 10 millivolts. So it is minus 100 divided by 1000 volts. So 100 is considered 1 by 10. So minus 0.1 volt. So this is the answer I got. So correctly if you observe, previously your answer came above 10 volts, above minus 10 volts. Sorry, below minus 10 volts. Now the answer came above minus 10 volts we are getting. Actually your saturation limit is minus 10. If you are below that any answer, it is minus 10 I said. But your answer came minus 0.1 volt. Whenever the answer is coming minus 0.1, it is close to the origin we are getting. Whenever the answer is very close to origin, I think you are under linear region. So I think this answer is not falling under non-linear, it is falling under linear because the output is very close to 0. Any output comes close to 0, we call it as linear region. Any answer close to the saturations, we call it as saturations. I think this answer is under linear region. So you cannot justify in the subject open loop op amp is linear or non-linear. That will get decided by the gains what they have given in the exams. Okay, in general the gain will be high only. But sometimes to know your thinking, whether you know the subject well or not, they'll test you. At the time whenever they say low gain, this answer, whatever you got, that is correct answer. Because in linear region, whatever the answer you will get, that is correct. In non-linear region, whatever the answer you got, that is wrong. We have to go for minus V saturation. So here also we got a good conclusion. Saying that conclusion here is, here we have a good conclusion again. Open loop op amp. Open loop op amp. Open loop op amp. With low gain AD will work in linear region. So this is the difference between non-linear and linear regions. This is another golden point in our class. So like this, don't confuse. Subject wise you have to understand. If it is a low gain, anybody say in the exams, maybe op amps will go to the linear regions. If it's a very high gain, it will go to the non-linear regions. Very good, very good. Samesh, perfect. Your statement is 100% good. Gain is low, it is linear. Gain is high, it is non-linear. Perfect. You got the concept well? Nice, great. So this is about my today class about open loop subject. So I hope you understood open loop. Slowly we'll enter into the positive feedback. Typical concept it is. Next concept, I'll clear your mind about positive feedback system analysis. Okay? How to understand a positive feedback knowledge. Again, same question will arise whether positive feedbacks will work under linear or non-linear. That's the question. And whether virtual ground theory we have to use or comparative we have to use. These are the questions. I'll try to finish off with my analysis. Okay? Always two things you have to remember. If I use any principle, you have to tell that whether you have to use linear or non-linear, which region it is working. And another point you have to tell that comparative we have to use or virtual show. These things you have to clarify first. Okay? The clarification how to do is the class today. So don't believe that op amps open loop system, it works only in non-linear, they can work in linear also. But the special case here is AD should be less, they have to tell in the exams. Then only you can tell it is non-linear to linear it will work. So I'm expecting it's clear. So let us move to final steps. Let us move to the next step. What is the next step is positive feedback mechanism I'm explaining. Rahman, if middle you will never get the answer. Middle में कोई भी बात नहीं करते because in the middle the answers are non-linear. If you are not using it, middle का answers हमको नहीं चाहिए. Examiner will decide the answers like this. Whether the answer will come close to 0 or whether the answer comes close to the saturation. Only two cases. In the middle decides nobody will do in the sentence. So don't worry about that values. So telling minus 5 आते क्या है? Minus 5 first of all will not design it. Okay, we'll go to lower or higher values. Yeah. Vn is nearly equal to V minus. It's not nearly equal. We can take equal only directly. So come to the second topic. Second topic, positive feedback. Positive feedback. Next concept I'm analyzing, positive feedback analysis. Let us understand a positive feedback op amp. Positive feedback op amp. Same example I'm taking with the positive feedback I'm designing. This is your minus, plus. This is your output here, V naught. We have here plus 10 volts, V saturation, minus 10 volts. Your AD, I'm giving same, 10 power 6. High gain I'm giving, 10 power 6. And what I can say is, negative positive is there. So, same thing, I'm taking here, R is there. This is your input. The only thing is, positive feedback means you have to close the loop in positive side to the output. This is called as positive feedback in electronics. Positive feedback means very simple, just you have to connect output to input in a positive side. This is called positive feedback. We are applying here positive feedback. No problem. Other side, the statement is wrong. If the input is low, but the gain is 10 power 6, it will be non-linear only. Because my input cannot be below 1 millivolt. Okay? My small signal will start with 1 millivolt in application because my voice level will be generated an electrical signal in the order of millivolts, not in microvolts. That's why the statement will be wrong. Okay? You should not talk here inputs. You have to talk about gains. Gains wise it will decide, not by the inputs. Please remember this point, by the gains it will decide. So this is the positive feedback. And here we keep one resistor here as R1. We'll keep one R1. So this is the way some voltage division rule circuit I'll develop. Okay? So this is my positive feedback system in the class. Now can you see that here, again my investigation will start here. What is V plus here? I'm interested to know here what is V plus, and I want to know what is V minus. Some students can think, sir, R1 purely means to create some positive potential here in the class. A V plus, I want to need some potential. That potential may come due to this current flow, some drop will come that will become V plus. Previously V plus is ground we have taken. Now V plus you can get some quantity there. V plus you can get some quantity there. Okay, let us start thinking what is your V plus and what is your output in the class. So one thing when you start the positive feedback analysis, one important point here is already inside the op amp we have some offset. Vi0 offset will be there. So in positive feedback systems or open loop systems, we don't want to nullify these offsets. Offset is a word we want to nullify only in negative feedbacks. We want to use offset in our subject because positive feedbacks will work like oscillators. Oscillators does not require external input. The input should come from inside only, called noise input. That offset is an unwanted input. I want to keep it like that. If unwanted input is there, offset, which is around suppose 10 millivolts suppose is your input. This is your external input. You're giving, both you are giving. This is suppose 10 millivolts. So you can see offset value is also same order. Your input external is also same order. First of all, if there is no input, offset is running already in the class. First assume that there is no input, offset wise some output came. As the input is 10 millivolts here, positive answer, the output will become here plus 10 volts. So that means the output is 10 volts we got because AD into VR0, so output will become plus 10. Okay? So if you want to teach this positive feedback, your input, you leave it otherwise. If you have any confusion in this example, we'll just leave it this so that you'll get a clarity. What I do is suppose here I made ground in the class. Both sides you are not seeing any input, but he is telling that there is some input called offset, which will be inside here. The inside input is 10 millivolts. Then what is the output? The output can be written as simply the output. We can explain like this. What is that output? I'll take the model and I'll explain. See here. This is ground here. This is ground. We have some R here. R is there. Next we have some V minus and we have ground. This is Zera is infinite. Model I'm writing again. This is a voltage source. This is a voltage source. AD into VD. Next we have short. Z0 is equal to 0 and this is output. So this is where you're seeing the model. But what is the extra thing you have done is, from the output you have taken some feedback and you connect it to the plus point. So this is your plus and this is your minus. So you connected some feedback here. So there will be some feedback like this to the output. This is your R2 and this is your R1. So in the AC model, this is the situation you created. This is the situation I'm seeing. Okay. Now if I ask you, what is this voltage? What is this voltage? And what is this voltage? This is already inside. Some Vi0 is there, 10 millivolts suppose. The difference between V minus and V plus. The offset is there. Okay. If there is offset, output is how much you have to find and input what is happening. So first can I write here, this is 0, this is can I say that first of all there is no current here? There is no current going here. So if there is no current entering here, can I say that I minus will be 0 here? And there is some current is coming from here. This is the current, which is the feedback current. But that feedback current is going to R1, where no current will go to plus side. That is I plus will be 0, because op amps will not allow the current to enter. So currents are not entering. Offset is not suddenly generated here. This theories we are applying with offset knowledge. Any op amps will have some input offset voltage, which is given by designer. So such offsets say unless op amps. In positive feedback, we don't give any inputs. Even in the coming class, the systems we are using for oscillators. That is the reason I'm taking offset thinking and I'm doing it. In the next topic, I'll tell you what is the offset, from where it is created inside the devices. Then I'll tell you afterwards. Just for study purpose, you assume that there is an offset here. You assume that inside there is an offset voltage. Then you start analyzing the concept. If input offset is generated inside is 10 millivolts, the subject is like this. So whatever the current you are seeing here is a feedback current coming here, where no current is going to the positive side. This is the situation in the positive feedback analysis. Again, my rule is, shall we use virtual ground theory or shall we use a comparator? Somebody asked me a question. Then how will manage the question? You can see. This is V minus here. This is V minus, and this is your V plus. Now seeing the board, you can tell what is V minus here is. It is 0 minus I minus into R. Because there is no external input in positive feedback I have taken in the class. If there is no external input, it becomes 0 minus 0, it will become 0. So V minus became 0 in the class, in this concept. Yeah, the previous topic also offset is there, present topic is also offset is there. Okay, look, maybe offset होते, positive feedback maybe होते, but negative feedback will nullify it and will study the negative feedbacks. In negative feedback offset को हम nullify कर रहे हैं, but ये topics में छोड़ दे रहे हैं आप. You're not controlling anything. In negative feedback we are controlling it. Okay. Previous topic को भी offset use कर सकते, no problem. So V minus is equal to 0 minus I minus into R. So answer becomes 0. So V minus is 0 in the board. And what is V plus here? If I want V plus is equal to, you can see that it is just looking like a voltage division rule circuit. Okay, it's a voltage division rule circuit. So what is V plus here is total voltage is V0 into that resistance R1 divided by R1 plus R2. So this is your V plus answer. V0 into R1 by R1 plus R2 we are getting. So this is my voltage drop V plus. So this is 0 we got, that is that much. But what is V0? If anybody asks me, V0 formula if you see here, V0, your output voltage is AD into VD. Your output is AD into VD. But answer became AD is AD only, but VD became VI0. That is what the person want to tell is, if there is no input given externally to the op amp, your input will become input offset voltage. If externally you have given some input, that will become your VD. Okay, external VD will be there, internal VD will be there. I have taken here internal VD for the study purpose. Okay, we have taken internal VD. So VD became VI0 in the class. So AD in the problem is 10 power 6 for you. Your AD is 10 power 6 here. Okay, into VI0 is 10 millivolts. So answer is again 10 power 4 volts. We got around 10 power 4 volts, but 10 power 4 volts is wrong answer. It will be plus V saturation will be the correct answer. So we cannot do more than the plus 10 battery, correct? So our output will be plus saturation we got. So finally I understood V plus is a plus V saturation into R1 by R1 plus R2. This is your V plus I found in the class. So V minus I found as 0 using offset subject. V plus I found it as plus V sat R1 by R1 plus R2. Like this we got two different answers. Can I feel that the answer never be 0 because plus V saturation is a battery, R1 R2 are resistors, they cannot be 0, but this answer becomes 0. So I can confirm that your V plus is not equal to V minus. I think I have seen that positive feedback and open loop system have the same principle we are using called comparator. So to prove that, this is my analysis actually. Finally I have to prove to a person V plus should not be equal to V minus. I prove it, but with the help of offset I prove it, with the help of input also you can do it. What you can take. Just to know some indirect knowledge for the student, I am explaining this. In positive feedback, offset you are considering in the classes. At the time my situation will be like this. Yeah, if you don't consider also we can solve it, that's not a problem. But let us understand offset if it is there, this is the situation. So V plus is equal to V minus. So that means it is working as a comparator role we are applying. It is also behaving as a comparator. So op amp in positive feedback will behave as a comparators. That is the proof is completed. The second point, your output is working in saturation levels. Your output is working in saturation in positive feedback means your output here, whatever you have seen here, is directly have taken as AD into V. And I said that output is under plus V saturation, correct? So I can say a confirmation here again. Conclusion I can tell you that it is working under non-linear area again. It is working under non-linear area. It is working under non-linear analysis. So we can write a conclusion here. So a small conclusion here. Conclusion. What is the conclusion here is positive feedback op amp always positive feedback op amp always work in non-linear region irrespective of open loop gain. It can be low or high. There is one important statement which I have to visualize for you. What is the visualization you can see? Positive feedback is telling that it will work in non-linear region always. Okay, previously what I said, open loop op amp can work in linear, can work in non-linear. But positive feedbacks are telling we always work in non-linear. So no doubt it works in non-linear. Irrespective of open loop gains, AD. You see here, 10 power 6 into 10 millivolts, it is 10 power 5 is a plus V saturation. Student may get it out, sir. Here AD I'll keep only 10, it will go to linear region. But here the concept is, this is not my transfer function for closed loop system. That's an open loop system answer, output. But what is the closed loop gain? If anybody want, the formula is different. Your closed loop gain answer is output divided by input. Output by input. Your input signal you have to take now. But input signal in positive feedback, what I have done is output by 0 I have made. In positive feedback techniques, what I am doing is my input signal I make a 0. If my input signal is 0 for oscillator techniques, can I say that your closed loop gain is becoming infinite? So irrespective of your output, whatever you take, it may be low output or high output by 0, ACL is becoming infinite. So you have an infinite gain in the class. If you have infinite gain like that, whatever may be the input, you give, small input, microvolts also, the output will go to plus V saturation. So that's why the systems never accept to be in linear region. But op amps will accept it. But positive feedback never accepts to be in linear. It will be always in non-linear in electronics. Examiner may give low gain also, examiner may give high gain also, you will be in non-linear because closed loop gain is close to infinite. That's वही बता रहा हूँ यार. वही बता रहा हूँ. It may be linear, low or high. My answer will be always positive feedback op amps always work in non-linear only. It may be low or high AD. Because this is closed loop gain, that is open loop gain. This is closed loop gain. The closed loop gain is close to infinite in the class. We design in such a manner, the closed loop gain will be infinite. So always remember, a positive feedback gain will be very, very high compared to open loop gain. Okay, because positive feedback means you're regenerating your energy. It will go close to the infinite, such that any input you go, you'll be in saturations. So that is the beautiness of second topic. Okay, most of the people will think, here also we can be linear, we can be non-linear. But there is no chance for that because my gain is changed. My gain is not AD now, my gain is ACL, closed loop gain, which is very, very high. So this completes my second topic. The last topic will complete today class. After that, break will be given for you. Then we'll start the amplified designs in the next class. I hope up to here it is smooth and clear. I'm expecting. This is about positive feedback mechanism. So don't get confused with offset. Offset is my next class. There I'll give the meaning of offset. Here only understand that in op amp they'll give some offset information by designer. We'll throw it and we'll understand the subject like this. In positive feedback we are not controlling the offset, but in negative feedback we are controlling the offset in the classes. Okay? Positive feedback we need the offset actually to do the applications because they're all non-linear applications. But linear applications के लिए offset को 0 करके we'll start the classes. Yes, positive and closed loop gain are same. There's a closed loop positive feedback gain. ACL means there's a closed loop. Like that negative feedback also will have some gain. There's a positive feedback gain. Chalo then, last topic, which is a very crucial topic called negative feedback is a different story. Let's see. So Pandit, if you want to understand these effects, if I have offset and input is also given, if you want to understand these classes, you have to wait up to non-linear applications called spin triggers. In spin triggers, we have offset, we have input also. There I'll explain beautifully what happens. Here don't ask all these things. For example, I explain this topic. Okay? You take up to here, don't visualize the feature techniques. Feature में बात करते हो पूरा conditions. Here at least आपको fundamentals चाहिए. Sir क्यों बोल रहे हैं? वो non-linear region में why it is going up to the limit you study Pandit. Remaining things when it comes I teach in op amps. Okay? Non-linear application में समझ में आता है. Input पे दे सकता हूँ. At the time what happens? There I'll teach you the subject. Here only study about offset का knowledge से complete कर दीजिए. So the last topic, give me some 10 to 15 minutes time. After that I'll close this topic. The last topic. feedback op amp. Keep the final one. यशवंत ऐसे वेरी सिंपल यार, क्लोज लूप क्यों बोल रहे हैं? क्लोज किया ना यार लूप को, ऑप एम्प का सिस्टम को क्लोज किया ना आप, उनके लिए क्लोज लूप बोलते हैं. पॉजिटिव फीडबैक मींस पॉजिटिव साइड क्लोज किया, नेगेटिव मींस नेगेटिव से क्लोज करूंगा अभी. क्लोज लूप सिस्टम will always be a contact between output and input. There must be some resistance. It's called closed loop system. Yeah. Shabanidas, yes, exactly. Arpita, show me the open loop op amp output voltage part. So not possible here. First complete कर दीजिए. Next topic complete करूंगा. Then I cannot sit here to move the slides. So whatever you miss that point, okay, you can just watch in the video. Night को आ जाएगा ना, वो वीडियो देखकर कॉपी कर दीजिए. Okay, it is not possible to manage the slides like that. थोड़ा वेट करो. So complete कर दीजिए. Before the slide, if you want, now only I can show you. Don't ask me in the previous case. So ये slide है. Arpita, if this is the slide, एक बार देखो fast. No, Professor, for the positive negative feedback closed loop gain is negative in nature. Gain is not negative, my friend. Okay, gain will decrease because it is negative effect. Gain negative आने के लिए रूल नहीं है. AD is 10 power 6 एक में आया, एक में infinite आया, एक में 10 आ सकते हैं. That's called low gain we call. Okay, that is the meaning called low gain. It's not the meaning that negative feedback or negative gain आ जाएगा. So keep the heading last topic. Last one, negative feedback I'm applying. It's a special area. So try to carefully listen it. Negative feedback. Op amp. How it will behave? Negative feedback op amp. Understand this interesting topic. I'll take an example again. Same example I'm taking without disturbing your minds. Same example. This is negative. This is positive. Positive side I'm in ground. This is your output V0. And we have here some R is there. Here your input. Just only thing is a feedback I'm applying to the negative side. You take a feedback here, which is RF applied. Feedback applied to the negative side. So it's called negative feedback. Now what are the consequences will come here? The main condition here you have to write. Whenever you study negative feedback, the first important condition is offset Vi0 should be nullified. This is the extra work in the labs we do for op amps. If you go to the lab, the first work you do is you nullify the op amp, nullify the offset voltage in the class by using some potentiometer balancing techniques. वो nullify होने के बाद amplifiers will start. Otherwise what happens? You have your input inside. I have my input externally. Both answers will come to the output so that you can't distinguish what is your amplifier output. That's why first very important thing is offset Vi0 should be nullified in negative feedback. I'm not taking for all feedbacks. Okay? Offset Vi0 should be nullified in negative feedback. So how to nullify it? We'll see in the next topics. Here only understand that in negative feedback we are nullifying it. So no need of talking about Vi0. So therefore here Vi0 will become 0. So no need of having any input in the class now. We have only external input, there is no internal input. But in positive feedback what I said is external input we are closing for oscillators, input inside input we are keeping without nullifying it. So it is our matter to control. If you control it, it will become 0. If you don't control it, will be there. That is the difference. So if Vi0 is 0, can I have this AC model presentation? It is like this. This is R, this is Vin. Next we have is open circuit. Zi is infinite from here to here. Next we have AD, VD. Next we have a short to the output. This is V0, positive to negative. But the feedback where you kept is here you kept feedback. The feedback is going like this. So carefully see the model. Feedback you kept in the top, not in the bottom. So the structure came like this. Now the interesting point is, if I take this as V minus and this as V plus, again I want to investigate what is V minus and what is V plus in negative feedback. Surprisingly what I have seen is, the current coming from the signal is now becoming IIN. But the current going to the op amp is I minus, is 0. But the same current is passing IIN to RF. So can you see that the principle has been disturbed here? Previously, what is the principle is, these two currents are going same for both the mechanisms. Positive feedback, IN and I minus are same. In your open loop also, I minus, IN is same. But in negative feedback, it has got a path to go to the output by RF. It got a path there, in negative feedback systems. That's why what is the disturbance here we got is, IN, I minus are not same. I minus is inside the V minus, that becomes 0. And I plus is 0 here. So, then can I feel that? V minus and VIN, if I take this as VR voltage, here this is VR. What is VR voltage is? It is IIN into R. So I think your VR drop is not becoming 0 in this class, in negative feedback systems. Because IN is not 0. So what is V minus here is VIN minus VR is V minus. Previously what happened is V minus and VN both are same in the class because the VR is 0. But here VN minus VR is V minus. By this you can tell your V minus is not equal to VIN. So this is the story coming in, negative feedbacks. In the other previous cases we have V minus become VN. But in this case V minus and VN are not same because VR drop is existing in the class. The type of things are happening in the op amps. As V minus is not equal to VIN, what is V minus? This is the question mark I got in the class. Then I have got a question mark in my face. So what is V minus then? This is a question mark. Then one of the scientists started investigating. Okay, V minus is what? As this is not equal to this. This is not only coming from this is coming from output also. That means I started investigating from output now. You can see what is output here is AD into VD because you are taking feedback from output to input. Maybe that V minus is coming from the output. So I started with output knowledge. What is here? AD into VD is V plus minus V minus. So you are expecting what is V minus in the class. Means this answer you want. Then what you can write is V naught by AD is equal to V plus minus V minus. Then I investigated what is V minus is. It is V plus minus V naught by AD. So this is actually the V minus in negative feedbacks. One of the important formula for the complete negative feedback analysis. So this is V minus which is coming from the output feedback. So whatever you have question mark here, I have been justified it. Your V minus is nothing but V plus minus V naught by AD times is coming from the output voltage. Now suppose if if I consider AD is very high in our classes, which is a general op-amps have very high gain. So if AD is very high, if AD is very high, I consider, then what is going to happen is V naught by AD can be neglected. So V minus will be equal to V plus. Can you see that now these two answers become equal? V minus is equal to V plus. The rule is correct when AD is very high, such that the denominator becomes more and more. This total answer will be close to 0. So whenever AD is very high in the exam point of view, you can take V plus and V minus both are same. This only we call in our electronics as virtual ground, or we can call it as virtual short theory. Virtual short theory we call. So like this, in negative feedback only, this special property is coming in electronics. V minus and V plus both are coming same. Yeah, that's you are right. This is equal to that also. But actually, now I investigated V minus from the output I investigated. Okay, because this information I don't know. I have this information. I started to analyze it. Either side arrow, left side arrow, right side arrow, your answer is correct. But generally, we want this knowledge because I want to investigate that V minus from the output, how much is coming back. It is coming V minus is equal to V plus. Whatever you are giving to non-inverting side, that only coming to the inverting side. That is a beautiful knowledge called as virtual ground or virtual short theory in electronics. Okay, this makes us to understand virtual ground theory wherever you like. We cannot apply in electronics. Whenever the question is under negative feedback, then only we can apply the concept called virtual ground or virtual short theory in electronics. If it's a positive feedback, we have to go for comparator. If it's a open loop system, we have to go for comparator principle. If it's a negative feedback, we have to go for virtual short. But there is one more problem with virtual short theory is there is one more problem here. Suppose if anybody say if AD is low, if you say in the class, if AD is low, this is AD is high. If AD is low, then V minus and V plus you cannot take same. There are two situations we have to understand. That means virtual short theory is acceptable only when the gain is very high. Open loop gain is high. If the open loop gain is very less, this is less value. You cannot say these two are same because minus of V naught by AD will come into account. That is the main reason. You have to understand the topic very comfortably in the exams. They said AD low or high, you have to decide first. If anybody say AD high, I'm so happy. I can go for V plus equal to V minus directly. If anybody say AD low, then also you done like this. You get a blender mistake called more error will come for you in the class. That means you are not neglecting this part. You are considering that part for AD low value. So virtual short theory is not acceptable. In this case, your virtual short is not acceptable. This is the beautiness of the concept. Virtual short, we cannot accept it. Okay. So finally, I think the story is completed. And V naught is equal to V naught by VIN, which is your closed loop gain, will be closed loop gain will be low value because you are applying negative feedback. So maybe the gain will come low by using some formulas. In the next class, we'll derive that formulas. ACL will come low value. When the gain comes low, we can say that okay, op-amp will be in linear region. Op-amp will be in linear region. So negative feedback systems, whenever you can control your gain, ACL value, low value if you can design, because closed loop gains is under my control, user control. So we can control it, closed loop gains. If I can control the gain to very, very low value, you can say that your op-amp will be under linear region. So linear analysis chahiye to, we have to go for negative feedback systems. If you want non-linear region, we can go for positive feedbacks or you can go for open loop systems. This is the complete clarity about the concept. Op-amps will be in linear region. Because of low gain design, we can do it. So today class have been completed successfully the basics of op-amp. Okay, all fundamentals are clear. You can attack the subject very easily in one course. After the break, we'll start the concept. Now it is nearly 1:15. 2:15 we'll start the class. Okay, you have 1 hour break I'm giving for you. 2:15, relax and comfort. 2:15 we'll start the subject. So the break time will be up to 2:15. I'm going to start the class. It is 1:15 now, exactly 1 hour. 2:15 we are going to start our amplified design spray class. Samresh, these applications we never use for comparators. Maybe V plus is not equal to V minus, but we are not using like a comparator these systems. Comparator if you want, go for open loop systems. Okay, virtual ground if you want, go for negative feedback. Maybe V plus not equal to V minus only about B. We are not using this application for comparators. Okay, comparator especially we use with that concept. Vidyadas is an able higher. 230, 240 AKR. 1 hour break is more sufficient. Okay, 1:15 to 2:15 you take. We'll start the class because we are in the final stages. Don't waste the time here. Okay, syllabus complete करना है यार. आपको पेन नहीं होते, मेरे को पेन होते because each and every topic कैसे cover करना